Okay, so here's part 2 of Module 3, Lesson 1. This kind of picks up here on page 137 with a slightly different skill here. We're done looking at range and domain and mappings and tables for the time being. You'll be doing some practice problems on that shortly. But what we're looking at with the next few problems here, so the learn at the top of page 137 and then example 2 at the bottom of that page, and we'll also look at the check problem at the top of page 138 in a few minutes. We're looking at taking a graph, and even if there's not numbers and data here, we're at least interpreting what this data is telling us. So let's look at this question. So graphing the total time driven during your driving course can help you visualize the progress. A relation can be graphed without a scale on either axis to show the relationship between the independent and dependent variables. We're going to talk about this in a second, as you'll see. These graphs can be interpreted by analyzing their shapes. The values in the domain correspond to the independent variable in a relationship. The independent variable, usually x, and for our purposes, it's always x, has a value that is subject to choice. In other words, days, like Monday is always Monday, Tuesday is always Tuesday. We're going to pick one day or the other. We can pick whichever day we want. In the graph above, the independent variable is the days. The values in the range correspond with the dependent variable of the relation. Okay? And in this case, it's always going to be y. So the dependent variable in this variable, the dependent variable is the variable in a relation, usually y, for our purposes always y, with values that depend on x. Right? How much driving time did you do? Well, that depends on what day you're talking about, right? So a dependent variable and an independent variable. So in the graph above, the dependent variable is the driving time. How much time did you drive? I don't know. It depends on what day you're talking about. Okay, so the difference between an independent and a dependent variable. So example 2 here at the bottom of that page, 137. Or, well, halfway down. So analyzing graphs. So the graph represents the number of text messages sent by Nora throughout the day. So we're being asked to do two different things here. Identify the independent and dependent variables of the relation. For our purposes, the independent variable is always the one on the horizontal x-axis. In this instance, time is the independent variable. And the dependent variable is texts sent, text messages sent. Okay, so then the next section here is just asking us to describe what's happening. Right, so this is Nora's text messages sent throughout the day. So I'm assuming here it's a cumulative amount and not an increase in the rate all day. Okay, so as you move from left to right along the graph, time, you could say, progresses or increases, right? As long as you express this idea that time is moving forward. As the number, and the number of text messages sent increases, right? Because as we go through time, as time increases, so does the number of text messages. Because this graph, let me change colors here, goes up, it increases. So the number of text messages sent increases until the graph becomes a horizontal line, or you could say a flat line. The horizontal line means that time is moving, time is going, but the number of text messages sent stops, right? It doesn't increase. During this time, Nora stopped sending text messages. Okay, well, she continued to send text messages Right here, she continued to send text messages until she stopped again for a period of time. Finally, Nora began sending text messages again. Okay, well, it doesn't ask us to, but what could account for this pattern? Well, she gets up in the morning, starts connecting with her friends, gets ready to go to school, right? She's getting showered, changed, eating her breakfast, whatever. Folks don't want her on her phone at the table. All right, well then, on the way to school, and as the day's ramping up, she's sending more texts. She's in school. She's not allowed to be on her phone. So that accounts for this flat line. And then at the end of the school day, she starts reaching out to her friends again. So sometimes she's using a little bit of imagination is what's called for, but the data is nearly always there in front of us to explain what's happening. Okay, so let's scroll up here so we can get to the next little bit. And then we're going to look at the problem, the check problem on the following page here. And this is just asking us to, again, use a little bit of imagination and see if we can match the graph to the scenario that they're giving us. Right. So, after an airplane takes off, its altitude increases rapidly. Once it reaches the desired altitude, it continues to fly at that level for a short period of time. Then the plane's altitude fluctuates slightly due to turbulence. Finally, the altitude decreases quickly as the plane lands. Which graph best represents this situation? All right, so airplane takes off, altitude increases rapidly. So as time goes, how is altitude, right? Altitude is this. How are they describing that altitude? It goes up quickly. So time is going, altitude goes up quickly. Well, compared to these other graphs, I would not say that that is altitude going up quickly. What's the next thing to say? Once it reaches the desired altitude, it continues to fly at that level for a short period of time. Then the plane's altitude fluctuates. Okay, so let's compare the remaining three here. Altitude goes up quickly, yes, and then fluctuate, level for a short period of time, and then fluctuates. Level for a short period well, that's level for a long period of time and doesn't show any fluctuating. Not that. This is level for a short period of time and then fluctuates slightly. That is not fluctuating slightly. That is definitely a disaster in the making. I would say this, B, represents this scenario the best. As time goes on, the plane gains altitude quickly, flies level, fluctuates due to turbulence, and then lands at its destination. Okay? So we're just looking at the graph and understanding what the variables mean. First of all, as time goes on, altitude goes up and comes down, and then the stories, for lack of a better word, that the picture is telling us. So what I want you to do is just get a little bit of practice with this idea of range and domain and independent and dependent variables, and a little practice with just interpreting graphs. So what I want from you is on page 143 in the practice problems. So page 143, I want numbers 1 through 6 done. You might need a little bit of scratch paper, so there will be some paper around for you to use if you need a little bit of space to write. Okay, so if you have questions, obviously I will be back to answer questions next class, but see what you can do here. Okay.